Students, welcome to Memoneet. I am Sakti Swarup, teacher of Memoneet. I am here to start with a new chapter that is capacitors. So we are preparing for the BTS 2, that is Brahmastra test series 2. Okay. So basically capacitor is included in the electrostatics chapter, in the same chapter in the NCRT. But I will teach you in a different way because capacitor, I think it have some weightage in the Neet also. Okay. So let's read capacitor separately. So what is capacitor? What do you mean by the capacitor? Capacitor is the system which stores energy in the form of electric field. Okay, we have a spherical structure like this, and a charge is present here. Okay, the charge is present here. This is positive charge. Okay, so the electric lines of force will be generated in like this. Okay, so capacitor means capacitor capacity to hold the charge, that is C is equals to Q upon V. Okay, so spherical set, the potential is equals to K Q upon R. Okay, so what will be the capacitance? C is equals to Q upon V, that is Q upon K Q upon R, that is equals to R upon K, that is equals to R upon 1 upon 4 pi epsilon naught. Okay, the value of K is 1 upon 4 pi epsilon naught, that is we can write 4 pi epsilon naught R. Okay, this is the capacity of the spherical cell to hold the charge. Okay, capacitance capacitance of conductor means thing, but the capacity of the conductor to hold charge per unit voltage. Okay, per unit voltage. So we represent it as C is equals to Q upon V. But let's say the unit of the capacitance. Okay, unit of capacitance is 1 microfarad. Generally we take it as 1 microfarad because 1 farad is a very large quantity, that is equals to 96500 coulomb. Okay, this is very large quantity, so we take the unit as 1 microfarad generally. Okay, generally we take it as 1 microfarad. When we talk about the resistance, R is directly R is equals to V upon I. Okay, but R doesn't depends on, okay, V and I. Like the same way, the capacitance will not depend on the Q and V. The capacitance depends on the size of the conductor, the shape of the conductor, the distance between the conductor. Okay, that is how the capacitance depends. The important point about the capacitance of an isolated conductor. The capacitance of an isolated conductor depends on the following factors, that is shape and size of the conductor. Just now I have told. On increasing the size, the capacitance increases. Okay. On the surrounding medium also, capacitance depends, because with the increase of the dielectric constant, the capacitance increases. Okay, we will read later on, because we have the formula, that is C is equals to epsilon naught A upon D. This is for the parallel plate capacitor, and when the dielectric changes, that is epsilon naught changes, then we have as it increases, then the capacitance will also increase. So these conditions we will read out, and no tension. Okay, so presence of other conductors. When the neutral conductor is placed near a charged conductor, capacitance of the conductor increases. So the neutral conductor, when present on the present near the charged conductor, the capacitance will increase. Okay, separation between the plates of the conductor does not depend on the charge of the conductor. Just now I have told, that is the capacitance will not depend upon the charge. Then the potential of the conductor, yes, and then the potential energy of the conductor. Okay, So these three conditions will not depend on the capacitance will not depend on. Okay, capacitor. Let's say we have two parallel plates here, two plates. Okay, this is of positive charge and this is of negative charge. Okay, and when they face to each other, they form the parallel plate capacitor. Let's find out the electric field at different regions. Okay, now let's say in this point. Okay, in the electric field due to the plate, we know that E is equals to sigma upon epsilon naught. Okay, to epsilon naught. So we have for the positive plate, it will repel, that is sigma upon 2 epsilon naught, it will repel sigma upon 2 epsilon naught, and for the negative plate we have minus sigma upon 2 epsilon naught, and it will attract. Okay, this will attract, that is sigma upon 2 epsilon naught. So minus is I told minus because of the direction, so it will be the negative of this plate. Okay, so these two have the same value, so it will cut out. Okay, so the electric field at this region will be 0. Likewise, let's say we find out the electric field at here. For the positive plate, the electric field will be in this direction, that is of E is equals to sigma upon 2 epsilon naught, and for the negative plate, it will attract in this direction, that is of the same quantity, that is E equals to sigma upon 2 epsilon naught. So this will cancel each other. So the electric field at this region, net electric field at this region will be 0. Let's say at point between the capacitors. Okay, for the positive plate, we have the force, the electric field in this region. Okay, that is sigma upon 2 epsilon naught, and for negative plate, it will attract. This is also sigma upon 2 epsilon naught. So the net electric field will be, E net will be sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. This will be equals to sigma upon epsilon naught. So this is the net electric field between the capacitors. You can write potential is equals to E into T. Okay, it means sigma upon epsilon naught into D. So what we will write for the sigmas? What is sigma here? Sigma is the surface charge density. It means we can write Q upon Q upon A epsilon naught. Q upon A is the surface charge density. So what we will write for the electric field? Q upon A epsilon naught into D. This is the value of potential. Okay. So the capacitance for the parallel plate capacitor is equals to Q upon V. It means Q, let's say we are taking it as capital Q. It will be more convenient. So capital Q. So Q upon V, that is Q D upon A epsilon naught. Okay. So what will be the answer here? Epsilon naught A upon D. So the capacitance for the parallel plate capacitor is epsilon naught A upon D. So we can predict that the capacitance is depending upon the area of the capacitors, area of the parallel plate, and it depends upon the distance in which they are kept. Okay, let's say their distance of separation is D here. Okay, this D is the distance of separation. Okay, so the capacitance will depend upon the area of the cross section and distance of the separation here. That is a capacitance depends on dimension of the capacitors, dimension, shape, size, etc. Okay, of the capacitors. Charged capacitor, we know that the voltage V is equals to W upon Q. Okay, so we can write that is work done upon charge. So what is the work done we can write? That is V into Q. So for the small work done, we have dW is equals to V into dQ. Okay. So what we can write for the voltage here? We know that Q, sorry, C, that is capacitance, is equals to Q upon V. Okay. So we can write here dW is equals to Q upon C, that is V is equals to Q upon C. Okay. So Q upon C dQ. So if we integrate this, so what we will get, that is dW is equals to, sorry, it is W will be equals to, that is work done will be equals to Q square upon 2C. So this is the work done for the capacitor. Or we can write, if we replace the Q here, Q, if we replace Q to CV, okay, what we can write, C square V square upon 2C, or this is equals to half CV square. Okay. And what else other we can write? We know that C is equals to Q upon C. Okay. So C is equals to Q upon V. Okay. That is equals to Q square upon 2 Q. Sorry, it is small q. Let's take small q here. Q upon V. Okay. So this will cut down. So what we can write? Half Q into V. Okay. So this is half Q into V. So these are the three formulas for the work done. That is W equals to Q square upon 2C, half CV square, and half Q into V. Okay. So this we have to remember. Density of the capacitor. We know that energy density is equals to half epsilon naught E square. So for the parallel plate capacitor, what we can write? We have taken that the value of E is half epsilon naught. The value of E is Q upon 2 A epsilon naught. Okay. Q upon A epsilon. This is the value of electric field that I have found out. Okay. So just put here, that is Q square upon A square epsilon naught square. So we have Q square upon A square 2 A square into epsilon naught. Okay. This is equals to sigma square upon 2 epsilon naught. So this is the energy density for the charged capacitor. Say we have a capacitor like this, and when it is connected to a voltage source, that is, let's say this is V voltage. Okay. Initially the capacitance is C and it have charge 0. Okay. When it is connected to the V voltage, the positive charge will tend to the, sorry, the higher potential will tend this plate to be positive because it is connected to the higher potential. So it will make C into V, and the negative plate, this will act as negative plate as it is connected to the negative end of the battery, that is minus of CV. Let's take another example here. We have the capacitor and here it is connected to the voltage source. Okay. But initially the charge on the capacitor, that is the voltage on the capacitor, let's say we have minus of 2V. Okay. So that is, this is positive plate and this is negative plate. Okay. We have given minus 2V, it means this is 2CV and this is minus of 2CV. Okay. And we have voltage here, that is 4 volt. Okay. So what it will do, it will make the positive end, the positive plate of the capacitor, which will be connected to the higher potential of the battery. So this will have, the final setup will have, that is, it is connected to the positive, the higher potential, that is 4 volts. So this, in this plate the charge will be that is 4CV, and this will act as negative plate as it is connected to the lower potential of the battery, that is minus 4C. Okay. So how much of charge from this negative plate, it has gone to the positive plate, that is minus of 2cv minus, sorry, it has 4cv at the end, so it have minus of 4cv. Okay, this is, that is minus of 6cv. So 6cv charge has already traveled from the negative end, negative plate, from the initial uh, condition, that is negative plate of the capacitor, that is in from this 6cv has passed out. Okay, has traveled along the battery, and then here the 6cv is terminated. So let's talk about the battery here. So we have battery, let's say like this, positive plate and negative plate. When we are giving any charge q to the battery, okay, so the charge q is moving from negative end to the positive end. So what is done, that is battery energy और चार्ज ले रही है, okay, ले रही है, so it is positive. So the work done by the battery will be q into v. Okay, that is, it will be in positive quantity. So if, let's say, we have like this and we provide charge to the battery like this, so in this condition battery, sorry, it is battery is acquiring energy, so battery energy दे रही है. Okay, and the battery is acquiring energy, so battery energy ले रही है. Okay, so this is the work done is equals to minus of q into v, so it will be negative quantity. Okay, about the heat loss is equals to work done by battery minus of final energy on the capacitor minus initial energy, minus of initial energy. So this is how we can calculate the heat loss. Here we have the capacitors, that is of capacitance C, and it is connected to the voltage, that is V voltage. Okay, so 4V voltage. Let's take 4V voltage. Here the capacitor C, and this is minus of 2 voltage. Okay, so the charge present on this capacitor, this plate of the capacitor, we have that is minus of, here it is negative and it is positive, so 2cv, and it is minus of 2cv. So at the final condition, when the uh, charge present on the capacitor will be according to the battery, so this will have this 4 volt, and this is the initial condition when the when the circuit is not completed. Okay, and when the circuit is completed, so the charge on the capacitor will be, this is 4cv, as it is connected to the positive end of the battery, and this is minus 4cv, this is c. Okay, so what will be the energy on both the capacitors? Let's find out. We know that energy is equals to half cv square, so initial energy is equals to half c. What is the potential on the capacitor? Here it is 2 volt, it means 2v square, so this will have 2cv square is the initial energy. What is the final energy? Final energy is equals to half c v square. What is the voltage around the capacitor? That is 4 volt, because this is because due to the battery, that is 4v square, that is equals to 16 cv square upon 2, it is 8 cv square. Okay, so now let's find out. We have here minus 2cv, here 4cv. So how much of charge it have collected? This plate have collected how much of charge? So we have 4 CV at the final condition. At the initial condition, we have minus 2 CV. So how much of charge it have collected? It means 6 CV we have collected. It means 6 CV charge it has collected. This plate has collected. Okay. So for that, the charge from this plate, the 6 CV charge from this plate must have traveled out, must have emerged out through the battery. So it is going from the negative plate to the positive plate. It means the energy, बैटरी एनर्जी क्या कर रही है, बैटरी एनर्जी दे रही है. ओके, इट इज गिविंग आउट द एनर्जी. सो वी हैव वर्क डन is equals to q into v. So how much of charge? That is 6 cv into v, that is 8 cv. Sorry, it is not v, it is 6 cv into 4v. 4v, that is equals to 24 cv square. So this much of work done is done by the battery. So heat loss is equals to work done by the battery, that is equals to 24 cv square minus in final energy, that is 8 cv square, minus of initial energy, that is 2 cv square. This will be equals to 24 cv square minus 6 cv square is equals to 18 cv square. This will be our final answer, that is for the heat loss. Take another example. We have here capacitor. When it is connected to another capacitor, let's say this is 5 volt and this is taken as 20 volt and this is 2 microcoulomb. Okay, and this is, let's say, 3 micro. Okay, these have capacitance of 3 microcoulomb and this have capacitance of 2 microcoulomb. So the charge initial condition, what will be the charge here? The charge is 40 volt. Sorry, for charge is 40, and here that is minus 40 microfarad. Okay, and so positive plate will be connected to the positive plate. So it has 3 into 5. That is, we know that Q is equals to CV. Okay, so I am putting C into V. So 3 microcoulomb into 5 volt, that is 15 microfarad, and this is minus 15 microfarad. Okay, so applying the Kirchhoff law, you know that Kirchhoff law. So on moving from anti-clockwise, we have we are moving from negative to positive. It means, let's take it as when these are connected, when these will be connected, this what they will want, they will want to maintain the same voltage between both the capacitors. Okay, between both the capacitors they will maintain, they have the same voltage. So minus 40 microfarad, this we are taking from minus 40 microfarad. It means from negative to positive we are moving. So let's say the v1, we are taking v1, and it is from positive to negative, minus of v2 is equals to 0. So this is according to, this is according to Kirchhoff law. Kirchhoff law. Okay. So V, what is the voltage? Q upon C. Okay. The charge here. Sorry. We have the charge. What is the charge here? Voltage between both the capacitor. The charge must be deducted and added in different plates of the capacitor. What it will be? So this, let's say we have 40 microfarad here, minus q charge is taken and it is transmitted to this one, which have 15 microfarad plus q, and this plate will have minus of 15 microfarad minus q, and this will have minus of 40 microfarad plus q. Okay, the charge must have transferred. So v1 will be 40 microfarad. We will take only for the positive plate. Okay, we will not take for the negative plate. So for minus 40 microfarad minus q upon c. What is the capacitance? 2 minus of for the here for the next capacitor, that is V2, that is 15 microfarad plus Q upon 3 upon 3. This is 2 microcoulomb and this is upon 3 microcoulomb will be equals to 0. So if we solve this out, that is equals to what LCM is taken as let's say 6 microcoulomb. So we have 40 into 3 120 minus of 3Q and minus of 2 into 15, that is 30 plus of 2Q. This will be equals to 0. So we have 120 minus 3Q minus 30 minus 2Q will be equals to 0. So this we have 90 is equals to 5Q. So the Q value is 18 microcoulomb. Okay. So here, sorry, yes, 18 microfarad. We have 18 microfarad. So here the charge that is transferred out, that is 18 microfarad. So at the final condition we have, that is here is one capacitor, here is another capacitor, and the charge here is 40 minus of 18, that is equals to 22 microfarad, and this will have minus of 22 microfarad, and here that is 15 plus of 18, that is equals to 33 microfarad, and this will have minus 33 microfarad. Okay. Common voltage here V1 is equals to V2 we have find out. Okay, so common voltage is equals to, put any one of the following. Okay, that is 40 minus that is Q upon C, sorry, we have find out, that is 22. V1 is equals to 22 upon 2, that is will be equals to 11 volt. Or we can also for the next capacitor, that is V2 is equals to 33 upon 3, that is this is also 11 volt. Okay, because we are finding out the common voltage. Okay, combination of the capacitor, let's say we have series combination of the capacitor. The series, we have two type of combination, that is series combination and parallel combination. Series combination is the one when the capacitor as are joined end to end. Okay, capacitor after another. Okay, but parallel combination is one in which all the capacitor are joined to the only 2 points. Okay, like this, the all the capacitor are joined to the two single points. Okay, like this. Let's say we have C equivalent is equals to, okay, in the series condition, we know that in the resistor, so what we have done in the resistance, we in the resistance R equivalent in the series condition is equals to R1 plus R2 plus R3 and so on. And in the parallel condition, in the resistance, we have 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Likewise, we will do in the capacitor. But the capacitor, in the capacitor, it is just reversal of formula. That is, in the series condition, we have 1 upon C equivalent is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3 and so on. And in the parallel condition, we have C equivalent is equals to C1 plus C2 plus C3 and so on. Here, we have to find out the charge on the whole set. Okay, so we have to find out the charge on the equivalent capacitance. So for that we have to do, that is Q is equals to C into V. So Q is equals to C equivalent into V. So that's we want to find out. Okay, so C equivalent is equals to, here the first, these two, let's say these two are in parallel condition because they are joined from two common points. Okay, so in the parallel I have told you that C1 will just add up, that is 2 plus 4, that is 6. Okay, so now this will become like this. Okay, and you have here and here. Okay, and this will attach to the 20 volt value, 20 volt, and this is 4 microfarad, this is 2 microfarad, and this will be 3 microfarad, and this is 2 plus 4, that is 6 microfarad. Okay, we know that in parallel we will just add it up. Okay, so here 6 microfarad, then 6 and 3 are in series. Okay, as they are joined end to end. So 1 upon 3 plus 1 upon 6, that will be equals to, let's say it will make it 6. Sorry, it will make it 6 by multiplying 2. Here it is 2. It means 3 upon 2 plus 1, 3 upon 6. So 1 upon C equivalent is equals to 3 upon 6. We are taking only two setup. Okay, only two capacitors. So C equivalent will be 6 upon 3, that is equals to 2 for these two capacitors. Okay, for these two capacitors we have equivalent of 2. So now it will become, then here one capacitor, here is 2 microfarad, and here it will be 2 microfarad, and this will be connected to the 20 volt battery. Okay. This is 4 microfarad, this is 2 microfarad, we have find it out here, and this is 2 microfarad it have given, and these 2 microfarad are in parallel. So when they are parallel, they will just add it up. It means 2 plus 2, 4. Okay, so now it will become like this. It have 4 microfarad, here it is 4 microfarad, and it is 20 volt battery. It is 20 volt, it is 4 microfarad, and this is also 4 microfarad, and these two 4 microfarad are in again in series. So what we will do, C equivalent, 1 upon C equivalent is equals to 1 upon 4 plus 1 upon 4, it is means 2 upon 4. So C equivalent is equals to 4 upon 2, that is 2 microfarad. Okay, so the C equivalent we find out, that is 2 microfarad. So what will be the charge? Q equals to C into C equivalent into V. It means 2 microfarad into 20, that is equals 20 volt is equals to 40 microcoulomb. So this is our answer. With this I complete my today's lecture. So half of the capacitor I have done it today and another half remaining. I know your burden is too high, so but you have to prepare for the BTS test series that will be performed on the 2nd June. So please be ready for that. If you are performing your daily targets, and attending the quizzes and also watching the video lecture, then it will go so smooth. Okay, nothing will be that is so hectic about that. Okay, so please be ready for the test series and try to attend each and every lectures, and please buy the BTS test series, because that test series according to that I am teaching, and it is too good. Okay, it is too good from any of the test series, because only the questions are from NCERT. So please buy that and be in a regular pattern, be in a synchronized way. Okay, make your preparation so smooth that in the 2025 examination will not face any type of difficulties. Okay, you will say that yes, I have done something great, that is that I can able to attend so much of question, I can able to attempt many types of question in different way. Okay, so please be ready for the test, in the upcoming test, that is on the 2nd of June. I hope so you are all doing great. Thank you, bye bye.